In this video, we're going to take a look at how we name alkenes, E-N-E. And alkenes are hydrocarbons that have double bonds. So just like naming alkanes, A-N-E, alkenes, we look for the longest carbon chain. So in this example here, we look for the longest carbon chain, and you might think, okay, the longest carbon chain is 1, 2, 3, 4, 5, 6 carbons. 6 carbons should be hexane, but we want to make sure to include the double bond. So we're looking for the longest carbon chain that includes the double bond. So in this case, we're going to have to go this way. 1, 2, 3, 4, 5. 5 carbons, and so that becomes pentane. Pentane. And because it is a double bond, we're going to change the ending from A-N-E to E-N-E. That tells us that we have a double bond. So E-N-E ending, and we want to show where that double bond is. And so we want to show that that's off of the first carbon. So that's going to be 1 pentene. 1, 2, 3, 4, 5. So it'd be 1 pentene. And you might ask, well, why didn't we start numbering from this end over here? Which is a great question. And so we want to have the lowest possible number that includes this double bond. So if we go this direction, then it would be 1, 2, 3, 4 pentene instead of 1 pentene. All right. Now, the other thing we have here is we have the substituent. We have the substituent here, and that is 2 carbons, and so that is an ethyl group. And we want to show that that ethyl group is off of the second carbon. So we're going to say then 2 ethyl, 1 pentene is the name of our molecule. And we can take a look at this one over here, where we have a different substituent. Here is chlorine, okay? So a slightly different substituent, and we have the double bond here in the middle. And the question is, well, if we have a double bond in the middle, how do you number it? So let's just say, for example, we didn't have the substituent here. Let's just say it was just 4 carbons in a row. In this case, it wouldn't matter if you numbered it going from left to right or right to left, it would still be the same. That carbon, or that double bond there, is still in the middle. All right, now, naming this, the longest carbon chain here, including the double bond, is 4 carbons, so that's butane, but we change the ending to E-N-E, so it becomes butene. Butene with the E-N-E ending, and we're going to number this now. And now that we have a substituent on here, it does make a difference. We could go 1, 2, 3, 4 like this, or we could go 1, 2, 3, 4 going from right to left. And if you probably have guessed at this point, we want to have the smallest possible numbers. And so if we start over on this side, then that chlorine is going to have a smaller number than if we start going from this side. And so this one here, we're going to go from right to left. And we're going to say that our double bond here is after the second carbon, so that becomes 2 butene. All right. And then we have this chlorine here coming off of the first carbon atom. So this becomes 1 chloro, 2 butene. Here we have some alkenes that have more than 1 double bond, and we also have some cyclostructures, or hydrocarbons with ring structures. So let's just start out up here. We'll do the top 2, and then we'll come down to the ring structures. So this top one here, we have 2 double bonds. And so when we have 2 double bonds, again, we want to just find the longest carbon chain that contains the double bonds. So that's going to be 1, 2, 3, 4 carbon atoms. So that'll be butene. Butene. And we want to number this so that way we have the lowest possible numbers going left to right or right to left. And so if we go 1, 2, 3, 4, or we go 1, 2, 3, 4 like this, either way it's going to be the same. And so our double bonds are going to be after the first carbon and after the third. And so this becomes 1, 3 butene, but we want to show though that we have those two double bonds, okay? And so we're going to change the ending on this. This becomes butadiene. So butadi, and the di is showing us that we have two. We're dropping in some Greek here. Butadiene, E-N-E, showing that we have the two double bonds on there, and there's a total of 4 carbons. Okay, let's practice another one here. Here we've got 2 double bonds, and we have a substituent here of bromine. And so the parent longest carbon chain on this is 1, 2, 3, 4, 5 carbons, so that's going to be a pentene. Pentene, but we have 2 double bonds. And so we're going to end up changing that and adding a little bit of Greek here. It's going to become pentadiene. I'm going to change the ending here to pentadiene. Pentadiene. And let's see, now where are these double bonds going to be? Well, we could go left to right or right to left, but what we're going to want to do is end up with the smallest possible numbers. And here we have the substituent over here on the right-hand side. So we're going to number starting from the right and going this way. So we'll go 1, 2, 3, 4, 5. And our double bonds are after the first and the fourth carbon atom. So that becomes 1, 4 pentadiene. And then we also want to show where that bromine atom is. So this bromine substituent is coming off of the second carbon, so that becomes 2 bromo. 2 bromo, 1, 4 pentadiene. Okay, now, if you're up for a real challenge, let's take a look here at the ring structures. Now, these ring structures, I've just drawn the skeletal structures, and in a previous video, we learned that wherever we have these points, that's where there would be a carbon atom. And this is just organic chemists being kind of lazy. So in this ring here, we've got 1, 2, 3, 4, 5, 6 carbon atoms. 6 carbon atoms would be hexane. And because it's a ring, we would call it cyclohexane. And because of the double bond, it goes from cyclohexane to cyclohexene, E-N-E. All right, well, let's take a look at this one. How are we going to name this one? Well, we want to have the longest carbon chain here with the double bond. And so this is going to be a cyclohexene. And we're going to start out here going 1, 2, 3, 4, 5, 6. Now, we could have gone in the opposite direction. What if we started here and went 1, 2, 3, 4, 5, 6? Well, if we did that, then our double bond here would have the same number. It's starting out with a number 1. But then these substituents would have higher numbers. And so we want to have the lowest possible numbers. So we're going to go clockwise in this case. Clockwise in this case. All right, so this here is going to be a cyclohexene. Okay, cyclohexene. I'm going to go down here. Cyclohexene. And if the double bond is coming off of the first carbon atom like this, we don't have to say 1. Okay, we would say one cyclohexene is showing that the double bond is coming off of there, but if it's off of the first one, we don't have to. So that becomes optional. So I'm just going to leave that one out here. Okay, cyclohexene. And then we have some things attached to it here. We've got two substituents. Here we have an ethyl group. And here we have a methyl group. Ethyl and methyl. And when we do this, if we remember from a different video, we want to do this in alphabetical order. So we have an E and we have an M. So the E comes before M alphabetically. So we would say that this here is 3-ethyl. Let's go 3-ethyl. And then 4-methyl. Cyclohexene. Now, looking over here at this one, we've got 5 carbon atoms. 1, 2, 3, 4, 5. And then over here, we've got another carbon atom coming off of that as a substituent. And that one there is a methyl group. It's a single carbon atom. I recognize that from here. So I'm just going to name this one here methyl. Okay, there's a methyl group attached on to this cyclo structure here, this cyclo structure here. And we might number this, and we recognize there's maybe 1, 2, 3, 4, 5 carbon atoms. So it becomes a cyclopentene, and there's 2 of those double bonds. So it becomes a cyclopentadiene. And then let's number this here. So we want to number this so that way we have the lowest possible numbers, but we include these double bonds. So I go 1, 2, 3, 4, 5 like this. Okay, that's one way of doing it. The other way would be numbering it from the other direction. And I could go 1, 2, 3, 4, 5. And if I do that, our numbers end up being the same. So it doesn't really matter which way we do it here. Okay, so I'm just going to stick with this one. Now, let's see. We've got a pentadiene. So pentadiene. Pentadiene. So di means that there's 2 enes, 2 double bonds. Penta meaning 5 carbon atoms. And let's show where those double bonds are. They're after the first and the third carbon atom. So we'll go 1, 3. Okay, 1, 3, pentadiene. And then we want to show where this methyl group is attached. And so that methyl group is attached off of the 5th carbon atom. So that becomes 5-methyl pentadiene. So it'd be 5-methyl-1, 3-pentadiene.